good day everyone and welcome to my YouTube channel today. As usual, we are solving problems on electricity. Today we will solve problem 3. Problem 3 has three parts, the A, B and the C part. We have the A part of the problem. It says a 24 ohms resistor is connected to a 16 volt battery. What current will flow in the resistor? This should be a question mark. Um, a current, the B part says a current of 400 milliamperes flows in a 60 ohm resistor. What voltage drop will be developed across the resistor? Finally, the C part of the problem says a power of 600 milliwatt is dissipated in a circuit when a voltage of 27,000 volt is applied to the circuit. The question is determine the current supplied to the circuit. Okay, as usual, we are going to take the problems one by one. Okay, let us give it a start. We write solution. Solution A, let me bring that back. If you read problem A, it says a 24 ohm resistor. Okay, ohm, from the unit ohm, this unit is the unit of electrical resistance. So it means this 24 ohm is your R. So you write R equals 24 ohm. Okay, it's connected. This resistor, a standard resistor of resistance 24 ohm, is connected to a 16 volt battery. Okay, this is the EMF of the battery. If this is the only load connected to the battery, and we assume that the battery has negligible internal resistance, so a small r is 0, it means this is the only resistance in the circuit, and this 16 volt will be the potential drop across the resistor. So we say that our V is equal to 16 volt. Okay, here is the question. What current will flow in the resistor? Okay, our target variable is current. Electrical current is denoted by I. Now we have a relationship between R, V and I, which we call Ohm's law, and it says V is equal to IR. From here, you can see that we can make I, the subject of the formula, our target variable, we simply have to divide both sides by R, and you see that R cancel R, and on the left hand side you have V upon R is equal to I. Then since this is the subject of the formula, you bring it to the left hand side, as this is the convention, V upon R. We continue and say this is equal to, what is our V? Our V is 16, so we write 16 here divided by, what is our R? Our R is 24, so we write 24 here. Next, we bring our calculator and press 16 divided by 24. 16 divided by 24. So you can see that we have 0.67. Since this is a recurring decimal, meaning a decimal that repeats itself again and again, we can choose to simplify this one to get it in fraction. Okay, now in fraction, what number will enter 16 and 24 without any remainder? We know 2 can enter here, 8 times 2 times 8 16, and 2 into 2 1, 2 into 4 2. So you have 12 here, you have 8 here. Again, 2 can enter both without any remainder. So 2 into here, this will be 4, because 2 times 4 8. 2 into this will be 6, because 2 times 6 will give you 12. Again, here you have 4, here you have 6, 2 can still enter, 2 into 4, 2, 2 into this, 3. Now 2 cannot enter into them without any remainder. They are both uh, prime numbers, so our answer will be 2 over 3 in fractional form. Then you ask yourself, what is the unit of I? I is electrical current, and electrical current is measured in amperes. This is your result, or you can say in bracket, O 0.6 uh, 7 amperes in decimal, approximately correct to 2 decimal places. With this, we have solved A part of the problem, and without much ado, let's go to the B part. Let's bring the problem here. The B part of the problem says a current of 400 milliamperes. Okay, again, we bring out the parameters we are given. The current I is 400 milliampere. Okay, remember this is not the SI unit of current. The milli here is 10 to the power minus 3. So you say this is equal to 400 times 10 to the power of minus 3 in ampere. Now you have changed it to its SI unit. Flows in, look at the problem continues, flows in a 60 ohm resistor. Remember this 60 ohm, from the ohm we know this is an electrical resistance, so our R is equal to 60 ohm. um, the question is, what voltage drop, okay, is another name for potential difference, V. So it means what potential difference will be developed across the resistor. Again, we use Ohm's law relationship. V is our target variable, and the relationship between VR and I is V is equal to IR. Luckily enough, V is the subject of the formula, so we don't have to make it the subject. It is the subject already. So we substitute the values. Our I is 400 times 10 to the power of minus 3, and our R is 60. So we take our calculator and press, look at it, 400 exponential minus 3. So here you press 400, okay, 400 appears, exponential you press here, you see the E appears, and then is negative 3, so you press here, you see the negative appears, you press 3, this is 400 exponential 3, then multiplied by 60, so you press the 60, you see, times 60 appears, then you press equality sign, and you see your result is 24. So we have 24. We don't stop here. We ask ourselves, what is the SI unit of V? And the SI unit of V is the volt, denoted by capital letter V. With this, we have solved the B part of the problem successfully. Then we go to the C part of the problem. Okay, the C part of the problem says, look at it here, it says a power of 600 milliwatts is dissipated in a circuit when a voltage of 24,000 volts is applied to the circuit. Determine the current supplied to the circuit. Okay, this is electrical power denoted by P, so you say P is equal to 600 milliwatt. Watt is the SI unit of power, not milliwatt. Don't forget this milli is 10 to the power minus 3, so convert it to its SI unit. You just multiply the 600 given by 10 to the power minus 3, and then you put watt. Now, moving on, we are given the voltage as 27,000 volts. So voltage V is equal to 27,000 in volt, and our target variable, they say determine current. Current is denoted by I, so our I is the target variable. Then you ask yourself, what is the relationship between I, V, and P? Okay, P, electrical power, is given as IV. If you multiply current by voltage, it will give you electrical power. Now, our target variable is the I, so we make I the subject of the formula. We simply divide both sides by V. You see that? Divide both sides by V, V cancel V, and this implies that our I here equals P upon V. Okay, now we can substitute P. The value of P is 600 times 10 to the power of minus 3 divided by the value of V, and V is 27,000. So as simple as that. If cancellation will give you some trouble, you simply press here 600, then you press exponential, you press negative, you press 3. You see this appears. Then you now divide, because you are dividing here, divide this by 27,000. You see, divided by 27,000, and you press the equality sign, and you can see what you have. This is um, 2.22, so you have 2.22, you see, times 10 raised to the power of minus 5 here, times 10 raised to the power of minus 5. Now, times 10 raised to the power of minus 5, then you ask yourself, what is the unit of electrical current? Current is measured in ampere, so your result is 2.22 times 10 to the power of minus 5 in ampere. With this, we have successfully solved problem 3, and thank you for watching. Assalamu alaikum wa rahmatullah.